This video is about effusion and diffusion. By the end of this video, you should understand the difference between effusion and diffusion, understand the difference between average molecular speed and average kinetic energy, and be able to predict relative molecular speed of different gases. Effusion describes the escape of gas molecules through a tiny hole into an evacuated space. Consider the diagram here. The bottom of the container initially starts with no particles. All particles are in the top. The particles effuse through the small hole in the divider into the evacuated space. The rate of effusion is faster for lighter gases than it is for heavier gases. Consider helium and argon shown here. Helium is less dense than air, so the balloon floats. Argon is more dense, so the balloon sinks. However, over time, the gases inside the balloon begin to effuse out of the tiny pores in the balloon. Eventually, the argon balloon will rise and the helium balloon will dip. Notice, though, after the same amount of time, the helium balloon has dipped much more than the argon balloon has raised. This is because helium diffuses more quickly than argon. Therefore, the helium balloon is deflating faster. Diffusion, on the other hand, is the spread of one substance throughout a space or throughout a second substance. We can quantify the rate of effusion using Graham's law. Graham's law tells us that the relative rates of effusion of two gases at the same temperature and pressure are given by the inverse ratio of the square roots of the masses of the gas particles. The equation is shown here, though you won't actually have to solve this equation. What's important to understand is that heavier gases effuse more slowly than lighter gases. To explain this, let's consider the difference between average molecular velocity and average kinetic energy. Consider two 5-liter containers filled with different gases at STP. The temperature of those gases is directly proportional to the average kinetic energy. Therefore, if the temperature is equal, both gases will have the same average kinetic energy. Note again, this doesn't mean that all particles have identical kinetic energies. It just means that the average of the kinetic energy of the particles in each sample is the same. Rates of effusion and diffusion, however, depend on average molecular velocity, not the kinetic energy. So here we're looking at the V term in the kinetic energy equation. Therefore, if two gases are at the same temperature, their molecules are not traveling at equal velocities. The lighter gas will have a greater average velocity. As we see here, these variables are inversely proportional to one another. As mass increases, velocity will decrease, and vice versa. Apply what you've just learned to this question. Pause the video here, and when you come back, I'll reveal the answer. Welcome back. Here's what you should have gotten. Neon is the lightest gas, therefore it will have the highest molecular speed and the highest rate of diffusion. HBr, on the other hand, is the heaviest gas listed, therefore it will have the lowest average molecular speed and the lowest rate of effusion. That brings us to the end of this video. Let's review our goals. First, we looked at the difference between effusion and diffusion. Then we looked at the difference between average molecular speed and average kinetic energy. And finally, we learned to predict molecular speed of different gases.